Hi, I'm Sarah Rowley and I'm a Masters by Research student at the University of Salford, working in collaboration with Adria Lopez-Busals, Ricardo Rocha and Christoph Meyer. I'm studying the interplay between local and landscape scale variables in shaping aerial insectivorous bat responses across a fragmented Amazonian landscape. Land use change is the main driver of the global biodiversity crisis. It's estimated that between 1980 and 2012, more than 150 million hectares of tropical forest was converted for agricultural use. However, some of this land, and in particular the land cleared for cattle grazing, are typically abandoned after a few years, and this gives forests an opportunity to regenerate. This trend of abandoned cattle pastures and regenerated forest is now a significant feature of the Brazilian Amazon, with 22% of deforested land being occupied by second growth forests. These secondary forests do have the capacity to help preserve biodiversity, so it's important to understand how species respond to changes in the local habitat quality and fragmentation of the wider landscape. Bats are excellent indicators of the overall health and the level of disturbance within neotropical forests. And whilst there has been a lot of research on the responses of phyllostomid bats to habitat loss and fragmentation, limited research has been done on aerial insectivorous bats. My study aims to provide a holistic perspective of how local and landscape scale variables shape aerial insectivorous bat responses to fragmentation by jointly investigating three biodiversity facets: taxonomic, functional, and phylogenetic. Additionally, I will investigate the scale dependency of the relationships between those diversity facets and the local and landscape metrics. All data was collected at the BDFFP. This study area consists of various forest fragments, continuous forest, and study sites in the intervening matrix, which were originally used as cattle pastures but abandoned and now feature secondary regrowth forests of varying age and species composition. This figure shows how the various forest types and fragments blend together. This background photo gives you an idea of what the secondary forest now looks like. The BDFFP is a landscape with relatively low structural contrast. 33 sites were sampled in total, 8 within the forest fragments and 9 interior control sites in the primary forest. I analysed around 280,000 calls from 20 species and 5 families. I calculated the diversity metrics or response variables through hill numbers, selecting an inverse Simpson metric. I submitted local vegetation data, which was collected from each of the sample sites to principal component analysis, and retained the scores on the first axes. Using satellite images of the BDFFP, I've quantified compositional and configurational aspects of the landscape structure and calculated 3 landscape metrics at 6 focal scales, which range from 500 metres up to 3 kilometres. I've created a set of 11 candidate models based on ecologically plausible combinations of local vegetation structure and landscape predictor metrics, whereby each model includes a random term accounting for the nested sampling design. In order to investigate local and landscape relationships with the 3 diversity response metrics, the most parsimonious models were selected and a 95% confidence set created. Model averaging for the best model calculated parameter estimates, and hierarchical partitioning determined the variation independently explained by each of the predictor variables. This figure shows a summary of the model averaging results. There are subtle scale-sensitive associations for all 3 diversity facets with local and landscape scale metrics, and most of the variables seem to be having a negative effect on diversity. So even though we're dealing with a landscape with low structural contrast, we can still see that the 3 diversity facets are affected by local and landscape scale habitat attributes in a scale-dependent manner. Moving forward and away from the community perspective, my next task is to assess ensemble and species-specific responses by analysing bat activity, and I will be again looking for relationships from a scale dependency perspective. So just to say thank you to everyone involved in this wider project. Thank you for your attention, and I'm happy to take questions.